A world sits beneath an unbroken blanket of clouds, and for a long time that seemed to be the entire story. Venus was the hottest planet in the solar system, a place so hostile that it felt natural to assume it had always been that way. Then, the picture started changing. As scientists studied the planet more closely, they began finding signs that pointed toward a very different past. Not a small difference, not a slightly milder version of the world visible today. Evidence began suggesting that Venus may once have had liquid water and conditions far closer to those of early Earth. Suddenly, the surface no longer looked permanent. The planet visible now started resembling the aftermath of something rather than the original state. A world that appeared completely settled became difficult to explain. If water once existed there, then the Venus we see today is not where the story begins. It is where the story ends. The old assumption starts collapsing. Venus no longer looks like a planet that was always hostile. It begins to look like a planet that changed. And if that is true, something removed the conditions that once existed there. The simplest answer still seems available. Venus sits closer to the Sun than Earth. If one world remained habitable while the other did not, distance feels like an obvious explanation. The planets started in different neighborhoods, so they ended with different outcomes. But the evidence keeps pushing against that idea. Researchers examining early Venus increasingly find signs that liquid water may have existed there for extended periods of time. That possibility changes the picture immediately. Water is not a brief event. Rivers, lakes, and standing water require conditions that keep working year after year. That means early Venus may have remained stable far longer than expected. Now the familiar image begins breaking apart. Instead of a planet that was doomed from the beginning, Venus starts looking like a world that somehow maintained conditions that should have been difficult to maintain. The closer scientists look, the harder it becomes to point at the Sun alone and treat the mystery as solved. Venus is still in the same place. The evidence is what changed. A safe explanation starts losing ground. Distance may have influenced the planet, but it no longer appears capable of explaining everything on its own. And that creates a more difficult problem. If early Venus could hold on to liquid water despite receiving more sunlight than Earth, then something was allowing those conditions to exist. The simplest explanation is that nothing failed all at once. Conditions do not have to disappear all at once. A world can remain recognizable for immense stretches of time. Water persists. The world still appears capable of supporting it. Then, slowly, the balance begins to shift. That possibility starts bringing Venus into focus. Climate models suggest that as the planet received increasing solar energy over immense stretches of time, long-term changes in its atmosphere could gradually push conditions farther and farther from the range needed to sustain stable surface water. The shift is not sudden. The process unfolds slowly. The picture that emerges feels familiar. Water remains. The world still resembles a place that could support it. Then the balance begins slipping. As the environment changes, maintaining liquid water becomes increasingly difficult. The world that once supported it starts moving away from it. For the first time, the transformation begins looking understandable. Nothing has to break, nothing has to fail catastrophically. Venus may simply have crossed environmental limits that became harder and harder to resist. A habitable world slowly turned into something else. because the conditions required to keep it habitable no longer existed. The explanation feels complete. A world that once supported liquid water simply drifted beyond the range that allowed it to survive. The explanation feels stable, right up until the pieces stop behaving independently. Water disappears, and something else changes with it. The atmosphere changes, and the consequences do not remain isolated. More heat creates conditions that support even more heating. What looks like a collection of separate processes begins acting like a connected system. That shift changes everything. Evidence and modeling increasingly point toward a climate transition where water loss, atmospheric change, and greenhouse heating were not simply unfolding side by side. One change may have started pushing the next. And each new change may have made turning back increasingly difficult. The planet is no longer drifting. It is accelerating. A world that loses some water becomes more vulnerable to losing even more. The farther the system moves, the harder it becomes to return to where it started. The system begins reinforcing its own movement. The comfortable picture starts breaking apart. This no longer resembles a gradual environmental decline that remained predictable from beginning to end. It begins looking like a threshold was crossed. Before that point, recovery may have been possible. After it, the planet may have been pushed onto a path that became harder and harder to escape. The consequence is unsettling. Venus may not have lost habitability simply because conditions became hotter over time. A self-reinforcing planetary process may have taken hold and amplified its own effects, turning change into acceleration. And if a habitable world can move from stability to a point where the system starts pushing itself farther from recovery, another question immediately appears. Why did that happen there and not here? Venus no longer looks like a planet that was always hostile. It looks like a planet that once possessed the conditions needed for habitability and then lost them. That distinction changes the meaning of everything that came before. The planet did not lose only water, it lost stability. That is the deeper consequence revealed by the effort to understand Venus. Habitability is not a permanent property that a world acquires and keeps forever. It is a condition that must survive across immense stretches of time. It must continue working as environments change, pressures accumulate, and planetary systems evolve. What matters is not the planet visible today. What matters is that a habitable world may once have existed there. A world that appears completely hostile may have spent part of its history under very different conditions. Those conditions disappeared. The stability that allowed them to exist disappeared with them. The final lesson is not that Venus became hotter. It is that a world can stop supporting life if the systems that sustain it are lost. Venus lost more than its water. It lost the conditions that allowed a habitable world to remain habitable. And once those conditions were gone, the world that may have existed there disappeared with them.